This is Senior Algebra, Section 4.5, Solving Linear Inequalities by Graphing. So today, we're going to take a look at solving inequalities by graphing here. We're going to do some shading like we did in the last section, but this time we're looking for where they intersect here. So, in example 1, we're going to graph each of these inequalities here. Let's remind some things. We're going to start at -5. We're going to go up 2 over 1 because we're in slope-intercept form here. Things I want to look at here, remember when I graph, I'm going to use either a dashed or a solid line. In this case, I'm going to use a dashed line. I'm going to graph the other one here. Y is greater than or equal to -1/3 x plus 2. So I'm going to start at 2. I'm going to go down 1 over 3, down 1 over 3. In this case, I'm going to have a solid line because it is or equal to. So now I have to decide where I want to shade here. So let's look at the blue one here. I'm going to make what's known as a practice graph here. On a quiz or a test, you'd be given this practice graph. I'm just going to make a quick sketch of what I have here. So in the blue I have that one, in the green there is the other line. So now I'm going to look, and I'm going to put in 0, 0 for x. I'm going to put in a point, and I get 0 is greater than -5. Is that true? Yes, it is true. So I've determined where I shade here. So I'm going to shade there because 0, 0, the origin is true. So now when I put in my other line, I'm going to do the same thing. I'm going to put in 0, 0. And I get 0 is greater than or equal to 2. Is that true? No, that's not true. So I'm going to shade above that line, where 0, 0 is not. So remember, when we're doing systems of inequality, systems, where are they both true here? So I'm looking, where are they both true? Well, where both of them are shaded. So my final graph would look like this. I would shade where both of them are true. In this case, in the upper left-hand corner. Now, we may have to, in example 2, move some stuff around before we do our graphing here. So I'm going to get these in slope-intercept form. I'm going to move the 3x over. And I'm going to divide by 2. So I get y is less than or equal to -5 halves x, or -5 halves, plus a -3 halves x. I'm going to do the same thing for the other one. I'm going to move the 2x over, so I have -5x, -5y, greater than 10 minus 2x. In this case, I'm going to divide by a -5, and remember, when I divide by a negative, I do have to flip the inequality. So I get y is less than -2 plus 2/5 x. I'm going to graph each of these. So in blue, I'm going to start at -5 halves. -5 halves, that's -2.5. So I'm going to go down 2.5. Now I'm going to go down 3 over 2, down 3 over 2. I could also go up 3 and to the left 2, up 3 to the left 2. I look, it is less than or equal to, so it is going to be a solid line that I'm going to use here. In the second one, I'm going to start at -2. And I'm going to go up 2 over 5. In this one, it's going to be a dashed line because it is not equal. I'm going to do my practice graph now. So I'm just going to sketch each of these. shade them and see where they overlap, where they intersect. The answer is, again, just where they overlap. So in red, I take a look, and blue is there. So now when I look at the blue and I figure out where to shade, I put in a point, 0, 0. 0 is less than or equal to negative 5 halves. Is that true? No, that is not true. So where am I going to shade? Not where 0, 0 is. I'm going to shade on the other side. So I shade on the left-hand side. I'm going to do the same thing in the red line. Y is less than that, so I'm going to put in 0 for y, 0 for x. I get 0 is less than or equal, or sorry, just less than negative 2. Is that true? No, that is not true. So I shade where 0, 0 is not. I shade below the red dotted dashed line. I'm looking for where they intersect. What region do they have in common where the red and the blue overlap? That's going to be in that bottom left-hand region there. So my final answer will be that shaded region in green here. And then finally in example 3, in this one we're going to have 3 different equations or inequalities. So I'm going to graph each of them. X is greater than 2. That's a vertical line. It's dashed because it's not equal to at 2. Y is less than or equal to 5. That's a horizontal line at 5. It's a solid line. And then for the last one, I have to solve it. So I'm going to move the 4x over. I'm going to divide by negative 3. And of course, when I divide, I have to flip the inequality. I get negative 8/3 plus 4/3 x. I'm going to start at negative 8/3, negative 8/3. How many times does 3 go into 8? That goes in 2 times. 2 2/3. So I go down to 2 2/3. And from that point, I'm going to go up 4 over 3. Up 4 over 3. It's going to be a solid line because it is or equal to. So now I'm going to look at a practice graph. Now again, is a practice graph necessary? No, but it may help you if you're trying to determine where to shade here and you can't kind of do it all in your head. So I have the red line, I have the blue line, and I have the green line here. And again, these are just rough sketches just to help me figure out where I'm shading. So I'm going to start in the blue. Blue is y is less than, so I put 0 in. 0 is less than or equal to 5. That's true, so I shade below where 0, 0 is. I look at green. X is greater than. If I put 0 and 0 is greater than 2, is that true? No. So I shade to the right that. And then finally the red one, if I put in 0, I get 0 is greater than or equal to negative 8/3. Is that true? Yes, that is. So for the red, I'm going to shade above. Where do they all overlap? Where are the red, the blue, and the green all together? In that middle triangle. Now, do they have to be in the middle triangle? No, not necessarily. It just happens that in this problem, that is the overlapping part. So that's going to be your answer there, that triangle in there. It could easily be in the one above, in the triangle to the right, in the trapezoid to the left, whatever, it doesn't matter. But you just have to see where the graph overlaps for all of them.